continue with the study of company B. Let's see if I can find it. Type of TG, composite, B all. So let's open B all. Let's run our model good. Let's forecast. Now we can load our composite scenario, which we called, say, good combined. Also creates the, if you go to periods, it creates the combined forecast table, including the next accident period. Click on OK. And now what I'd like to do is go to the forecast summary. Let's go to HLFO. Click on forecast settings. Go to, say, future IOTAs. So we're looking at the line of business HLFO, homeowners, farm owners, forecast setting tab, and future IOTAs. And tile vertically, minimize other types. So it's only that table that's tiled vertically. Then click on model displays, and then click on tile vertically. So for HLFO, along the calendar years, we've got a zero trend in the data based in the model, based on the data, and yet to obtain the reserve distribution, we've assumed a minus 56.5% trend, standard error of 0, and in order to obtain the reserves held by the company, well, that means that the reserves held by the company must be awfully too low. But fortunately, HLFO doesn't represent a large proportion of its business. If you go to PPA, profit passenger automobile, the trend is huge, but it seems to be decreasing more recently. In order to get their reserve estimates, and this was only 10 by 10 years data, we had to kind of revert almost to the old trend. So, you know, unless you had a good explanation as to why this old trend would revert, you know, our forecast is quite conservative, our forecast scenario, which means the company's probably adequately reserved. If you go to commercial auto liability, well, we're assuming 17%. That kicks in immediately. Again, that's what's a development pattern, development share pattern? Well, they pay most of their money in about 1.5 years anyway. So, you know, the calendar year trend, I guess that's only pretty critical for the next year or two. If you look at workers' comp, 30% versus, don't worry about the fact this not being significant, which still left it there, it's 14%. And if we go to CMP, we assume 44% when they've only had 24% more recently. Okay. What we'd like to do now is find the distribution of the aggregate reserves. So we need to simulate, if we go to the forecasting table, we need to simulate from all these log normal distributions for each triangle, each line of business. So in order to do that, we go to PILD and we select the reserve. We want to do the simulation of the reserves 10,000 times, say, so let's do that. Takes a while because you've got, I think, 15 triangles. You're forecasting each to development year 15. So you're probably doing somewhere, I don't know, I think I've estimated before around 10, 12 million simulations from correlated log normals. Now go to the risk capital graphs and say click on say 95%, and you'll see that most of the risk capital at the 95% VAR goes to REA. REA is the one that needs most of the risk capital. The second one is WC. My guess is WC, well, let's see why. Let's go to forecast summaries and tile vertically now. Let's close model display, forecast table, tile vertically. In the forecast summary, why don't we go to the aggregate tab and then select LOB comparisons. And let's look at the pie chart. So workers' comp is only 8.7% of the business. But it has, what's its coefficient of variation? Oh, that's right. Workers' comp had the largest coefficient of variation. It's over 60%, so this is the reason. Even though it might have a low mean and a relatively low variance, because it's small in terms of the amount of business. It's only 8.7% of the business in terms of reserves, but because it's got a very large coefficient of variation, it's got the largest coefficient of variation of nearly 65%, you need to allocate a lot of capital to workers' comp. Okay, so now what we're going to do, we've just calculated the reserve risk. What we need to do now is I'd like you to load in a new window model good again, and then load it again. So we've got 3 instances in separate windows of model good. And now go to the, after we've done that, so now we've got 3 runs of model good. On the right, with the right side, with the right button of your mouse, click on the forecast dialog box, select all, and for each one, load good combined. Well, the first one has been done already, so I didn't do it again. Load good combined. And now we're going to do is compare reserve risk, underwriting risk, and the combined risk. Load good combined. And you'll see that even at a T-VaR, the combined risk charge should be less than the sum of the other 2 risk charges. So now you go to PALD with the right button, and let's do the reserve first that we've done before. While this is being done, I'll go to a PowerPoint display. Oops, doesn't want me to do it. That says something about Windows. Back in here. Next is future. So now we're doing it for the future. Excellent here. Next is combined. Go back to PowerPoint. File, demo. Okay, let's go to this display. So you can do the 3 different simulations while I'm looking at this. Bring up the pointer option, highlight pen, pointer in color. Right. Okay, so let's see now. So we have 3 runs of PALD. One of them is combined, one of them is future, one of them says reserve. Tile vertically, minimize other types, and scroll, look at the tab for risk capital graphs. Risk capital graphs. Let's suppose we look at the 95th percentile T-VaR on each side. 95% T-VaR, 95% T-VaR. And bottom left-hand graph. Now you might not be able to read what you've got there. I mean, I've changed the font size so it's easier to read. So you might have to go to graphic options and do some changes there. And let's look at this one. Now, the reserve risk charge, risk capital, is 5.99 million. The risk capital for the future accident year is 7.965 million. So the 7.9 plus the 5.9 is about 14. Yet the combined risk charge, the combined risk capital, is 12.1 million. So at the T-VaR, it's less. Why is that? Let's try and find out. Now, what's the difference between forecasting this next underwriting year versus forecasting the last accident year? It's only that single observation. That's the only difference. Now, in a PTF model, and also an MPTF model, aren't you relating the three directions? So when you forecast these cells here, you're using the calendar year trends in forecasting these cells, the development year trends. So when you look at the combined risk, you're actually forecasting more numbers. The reserve risk is just the sum of the distributions in all these cells. But then if you look at the combined, you're forecasting the sum of more numbers. And isn't it true that the whole principle of insurance and statistics also, it's easier to forecast the sum of many numbers than the sum of fewer numbers? Okay? So it's not necessarily true that the coefficient of variation of the combined reserve is larger than either the underwriting, the future accident year coefficient of variation, and the reserve coefficient of variation. And as a result of that, the combined risk is less, the combined risk capital is less than the sum of the two, which is not really something that rating agencies use. They actually add the risks, the risk charges. Well, that doesn't really make sense. Adding the risk charge is almost saying that the correlations are equal to 1. Okay, there's more of that kind of studies done in the demonstration videos on our website.